Hello, 8th graders! Welcome to lesson 10.6, which is all about writing scientific notation. So in the last unit lesson, we were talking about kind of reading your scientific notation and how to change it to standard form. Here are icons for this lesson. It is I can write large and small numbers in scientific notation. So we're taking things from standard form and we're going to put them into scientific notation form. And I can perform operations with numbers written in scientific notation. Okay. All right, skipping our warm up. Well, how can you write a number in scientific notation? Remember that with scientific notation, there is a very clear definition that we need to have a number, anything 1 through 10, being multiplied then by a base of 10 and some sort of exponent. So for right now, I'm just going to leave the exponent as x, and we need some number between 1 and 10. So maybe this time we're going to take 6. Okay, ugh, it's really bad 6, but it can be anything. It can have decimal places, but it can't be something like 60. 60 is not going to work because it is not a number between 1 and 10. Okay, so we're going to take a look at changing them from standard form to scientific form. All right, so writing a number in scientific form looks like we've got two different steps. So your first step is to move the decimal point so that it is located to the right of the leading non-zero digit. That sounds complicated. Basically, what it means is I want to move my decimal so that my number or that factor is somewhere between 1 and 10. So in this case, I didn't want to move it all the way up past the 8 because then it's not between 1 and 10, and I can't just put it after the 6 because then I'm going to have 86. So I want to put it right in between these two numbers. Basically, so it's located to the right of the non-leading, or the leading non-zero digit. So basically, you want it to have a number in front that is at least 1 or greater. Okay, that's basically what they meant by that. Step number 2 then is count the number of places you move the decimal place. So what you're going to do, like we've been doing with counting like that, you're just going to count as you go along, okay? This indicates the exponent of your power of 10, okay? Remember that anything that is small is going to be a negative value, okay? So basically this is just meaning that it's a small digit, okay? This is what that number between 0 and 1. It means that you're going to have something as a really small decimal. That's when you're going to have negative exponents because you're moving it. You're going to show that it's negative. This one then is your number greater than or equal to 10. So something that's larger, a large number, and you want to make it smaller by writing it in scientific notation or make it look a little easier to write, then you're going to have that positive number. Now this one's a little tricky because in theory when you move this direction you would think that you're moving in the positive direction, thinking about your number line. But remember, you have to go back and think about what's the actual standard form of this. Because it is a decimal form, the exponent's going to be negative. Since this was a large number form, it's going to be a positive exponent. Okay, this is where it kind of gets tricky on understanding if it's going to be negative or positive. All right, let's look at example 1. So I wonder if this is the true statement. I want someone to Google this while we're on YouTube. Lovely. I want you to Google this to see if this is truly correct. So a couple of years, quite a years back, I feel like I was either just finishing up high school or the beginning of college when Google actually purchased YouTube. So YouTube was the original, YouTube was owned by another company or people who had started up YouTube, and now Google actually owns YouTube. They've kept the name YouTube, but Google owns all the rights to everything on YouTube and owns it. So it says that Google purchased YouTube for $1,650,000,000. Write this number in scientific notation. Ooh, that was a lot to read, and it's a lot of zeros then to write. So we are going to change this into scientific notation, okay? I'm not actually going to rewrite this number, but I would suggest rewriting it, but I'm just going to use the decimal that they already have here. I'm also going to change my pen color here. Let's do something bright. I don't know. Yellow doesn't show up very well usually. Let's go pink. So I'm going to count how many decimal or how many spots it takes to get this over. So I want to make sure though that my factor is somewhere between 1 and 10. So if I was to leave my decimal place right here, I'm left with 16.050000. That is not between 1 and 10. So I'm going to want my decimal right here. So let's see how many times that took me to get that over. It would be 1, 2, 3. I'm not sure why it's cutting out. 4, 5, 6. 1, 2, 3, 4, 6. Yep. 7, 8, 9. Not sure why it's cutting out like that. That's weird. So it looks to be that I took 9 times to get over. Let's just make sure I got that right again. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It is kind of tricky, and so double check, triple check. You just watch me do it like 3 times to make sure I got it right. So my number then is going to be 1.65. So anytime I have actual digits and number values other than 0, I need to write them down. So I put my decimal right between the 1 and the 6. There's still a 5, and I don't need to have any of those other zeros left, okay? We're going to have it to the power, then multiplied by 10, and then to the how many places we went over, and we went over 9, okay? This is a really large number, so my exponent is going to stay positive. All right. Again, let me know if you've got questions. Feel free to email, text me. We can always set up Zoom chats privately if you are still really confused. I'd rather have you understand this than to be completely confused, okay? Make sure you're listening for your code word. Your code word will be important if I don't feel like you're trying your best, or maybe if I just asked for your code word, all right? Let's keep going. All right, example 2 then. The 2004 Indonesian earthquake slowed the rotation of the Earth, making the length of a day 0.0000268 seconds shorter. Write this number in scientific notation. I didn't know earthquakes had the power of lengthening a day on Earth, or like stop the rotation. It's probably because of it must have gotten so far down into the core. Let me guys know if you learned this in science this year, because I know you were talking about like the mantle and the crust and the core and the inner and outer. I'd actually be pretty intrigued to learn about this. So it must have gotten deep enough that it had kind of stopped that rotation a little bit to make it a little longer. All right, so we have a really small number. So when I set up my scientific notation, then that means that I'm going to have some integer, okay? And I'm going to have it multiplied by 10 to a negative power. I don't even know what that negative power is yet, but I'm setting it up because it's a decimal, so I know it's going to be negative. So then I'm going to start moving my decimal over, and I want to figure out where I'm going to put it first. Let's see. So if I want to get rid of these zeros for the most part, I could put it between 2 and 6, because 2.68 is between 1 and 10. If I went all the way behind the 6, then I have 26.8. That's too big. And 268 is too big. So we're going to want this decimal right in between the 2 and the 6. So let's see how many times that took us. 1, 2, 3, 4, 5, 6. I just want to double check again, make sure I get that right. So 1, 2, 3, 4, 5, 6. So it took me 6 times, so I'm going to have a negative 6 as my exponent. And then right where my decimal is, and then it's basically, I deleted all those zeros in the front. So now I'm going to have 2.68. And this is this number written in scientific notation. All right. I want you to go ahead and try these ones on your own. So try writing these numbers here in scientific notation. Your first three, as you notice, are really large numbers, so you should have a positive exponent. And these last three are small numbers, so make sure you have a negative exponent, okay? So take a minute to pause the video. When you get back, I will have the answers for you. All right, welcome back. Here are your answers for these 6 problems. So your first one, you should have 5 times 10 to the 4th. Number 2 is 2.5 times 10 to the 7th. I know it's a little hard to read there. Problem number 3, you get 8.6, or sorry, read it wrong, 6.83 times 10 squared. Remember, if you have any numbers that are not 0, they do need to be included, okay? Number 4, you'd also have a 5 as your factor, but this time you're multiplying it by 10 to the negative 3. Number 5, you get 3.3 times 10 to the negative 7th. And problem number 6, I know I could stump a few people, but you do need to put it in between this 5 and this 0 because you still need to include this 6. You can't just leave out the 0 and be like, oh, I took out an extra 0. That doesn't work. You have to leave it as the way it is. So I'm putting it in between the 5 and the 0. So I'd have 5.06. And this is going to be times 10 to the negative 4th. Okay. Let's keep rolling. All right. I think we've got 1, 2. Okay. We probably won't do those on your own. So I think we got 2 more problems. I don't know if I'm going to be able to get through them in the time allowed here on this video. So I think I'm going to cut this one just a little bit short, and I will see you back in the second one here for examples 3 and 4. Okay. If you haven't heard your code word yet, please make sure you're still watching out for it. Those will be important as we go through. Okay, I will check you in part 2. See you in just a minute.